All right, so well, let me do 20 because it won't take long. 20 we have f of x is equal to, oh hey, it's the exact same functions, x cubed, and then g of x is going to be the cube root of 1 minus x cubed. All right? And so what they want us to do is do f of g and g of f. So now watch this. This is f of something is equal to something cubed. And your textbook wants me to find f of g of x. So what I'm doing is wherever there's an x, I'm just plugging in g of x. But what is g of x?
Cube root of 1 minus x cubed.
Yeah, so it's all this stuff, right? So it's the cube root of 1 minus x cubed. And so I'm going to say the cube root of 1 minus x cubed. So now what happens when you cube a cube root?
Get rid of it.
I'm going to write this out so you guys see this using that property we just talked about. This is equal to 1 minus x cubed raised to the 1/2, and all of that is raised to the 3. So when I multiply the 3 by 1/3, what do I get?
1.
Raised to the 1, which is just 1 minus x cubed. So basically f of g of x is 1 minus x cubed. Does that make sense? Now, g of f is not necessarily going to be the same as f of g. So if I take the same two functions and I want to find g of some stuff, well, what I'm going to need to do is wherever there's an x, I'm going to put parentheses. I just broke my marker. Okay? Do you see that? Now, what is f of x?
F of x cubed.
Yeah, it's x cubed. So I'm just going to skip one step and put an x cubed in here and put an x cubed in here. So now if I go through and I finish the rest of this, I've got the cube root of 1, or I'm sorry, the cube root of 1 minus, what do I do with those two numbers? Add them or multiply? X to the 9th. Okay? That is, I don't think I can take that any further actually. Let me just double check. Sometimes you can factor things out. Nope. So now what is the restriction on this? Now the last thing they asked us, and I kind of skipped it on the last problem. So this is g of f of x. But what's the domain of this? Yeah.
You can't make the x to the 9th any smaller because it's a cube root.
Well, no, because this plus sign, I have to treat this as like a group. And so the only time I could use those properties of exponents is it's on factors. And if I factor this, there isn't a difference of cubes. I mean, there is, but it's like, it's not a perfect cube.
Okay.
And so, yeah, I need a perfect cube to take the cube root of it. And, yeah. You want to think that, but the answer is no, you cannot. Yeah. Good, good. Yeah, sometimes kids will say, well, can I take the cube root of this and the cube root of this? No. This is one binomial term. It's a two-term binomial, but I mean, you can't separate it because of that minus sign in between unless you factor it. This is factorable, but it doesn't factor into something times itself 3 times, and so taking the cube root, you can't. It won't reduce anything. I'll just go through a lot of work and factor this, but I can't pull anything out. We can only pull stuff out based on factors. Okay. If this was a multiplication symbol, oh yeah, then we can do some stuff. But because it's a minus sign, I can't. I got to treat that like a group, and then the only way I can do anything is if I factor it. That's a good question, though. So the domain, what are the restrictions on this? What are the restrictions on odd roots? There aren't any. So this is all real numbers. Let's go back and revisit the other one, okay? What are the restrictions on the domain on this thing here? There aren't any, so it's all real numbers, right?